Hello, good morning students. Today we are going to see the topic the need of data structure and the classification of data structure from the unit 1 introduction of data structure. So as per the definition of data structure, it's a particular approach of storing and organizing data in the memory, computer memory, so that these data can easily be retrieved at any time whenever it is required at the future. So the data can be managed in various ways. Like the logical or mathematical model for a specific organization of data is actually called as data structure. So here the diagram, it explains the various types of data structures and the various types of algorithms. So we have a choice to use the data structure for solving a problem. Like similarly, we have a choice to implement an algorithm in data structures according to the problem what we are finding it. So here you see the various examples, the types of data structures, like from linked list, stacks, arrays, queues, etc. Like on the right side you can see the various types and examples of algorithm, like searching algorithm, sorting, and divide and conquer, and greedy algorithm, recursive algorithm, etc. So what is the need of data structure? Of course, we know that data structure is providing the easier approach for organizing, retrieving, managing, and storing the data. But the following points, like where you see that, that creates the necessity of data structures. One is performance. So we need to choose the right data structure. So because the right data structure will have a strong impact in the program. So the performance will be decided how the program can be accessed and processed information. That's actually the performance. And the memory management. So data structure is also helping how to optimize the memory usage, and it prevents using the wastage of spaces, and it makes the program very efficient in execution to managing the memory. Like as it is mentioned, code reusability, which is the process of modularity, reusable of code with a well-defined data structures can be reused in different parts of program, even the programs, other parts of the program, like which will help to save the time, and it leads to promote the consistency of the program code. So what is the need of the data structure in terms of complexity, time complexity and space complexity? To improve the time complexity, the data structures are highly playing a major role. Say for example, when you want to search an element in a stored array, okay, which is faster than searching for it is an unsorted array. Okay, so searching a element in a sorted array is faster than in an unsorted array. That is that makes the difference in time complexity. So both programs are same, but searching in sorted array and searching in unsorted array make the time of execution differs. So to have the betterment of space complexity, the data structure is also helping to reduce the number of code, so that the memory can be saved, memory wastage can be achieved. For example, we have a choice to use the linked list instead of array, so that the amount of memory can be saved when storing the elements. So the other points, like when we want to have a efficient data retrieval, for example, in a hash table, if you want to retrieve data in a constant time while searching through an unsorted array, so it takes a linear time. That is one of the need of data structure. Another need of data structure is better data management. Data structures make it very easier to manipulate the data. Example, stack data structure, if you see that, so it is implemented in various programs, like infix to postfix conversion, right, and there is a game problem called towers of Honai. So like that, even the small action like undo, redo function in an application, so that is also easy management. So solving a complex problem is also another need of data structures, where it provides a foundation for the efficient algorithms and making it possible to solve the complex problems in a reasonable amount of time. Example, so if you take the graph traversals, like we have two different graph traversals, like depth first search and no, breadth first search. In both graph, the finding the shortest path is an important problem which can be solved through the data structure. So when you see the classification of data structure, there are only two categories. We have primitive and non-primitive, but in non-primitive we have linear and non-linear, another sub two categories. In primitive, all we have basic data types like integer, float, character, and pointer. Uh, so these data types we used to declare in the beginning of the program, but non-primitive category, we have linear and non-linear. In linear we have arrays and linked list, stacks, and queues, but in non-linear, graphs and trees. So here the primitive data structures or the basic data structures, what we are simply declaring uh, in the program for the functions and variables. And non-primitive data structures are separate concepts which we are implementing for the specific problems. So that makes the difference between primitive and non-primitive. And when makes the what makes the difference between linear and non-linear? Linear structure, we have data type, we have the examples of data structures like stacks and queues and linked list. Okay, even array also linear. But non-linear, we have trees, graphs, and some specific tables. So which has the one to many, many to one, many to many dimensions. But in linear, we have only one dimension. But in non-linear, we have multiple dimensions. Okay, thank you. Let us see in the next class with another topic. Thank you.